All right, so we're continuing on with square roots and perfect squares. So if I'm looking at this square and I'm telling you that I have one of the sides here is 3 centimeters long, how would I find the area of this square? So just think about that for just a second. Okay, so if you notice, a square has equal sides, right? So I know that it's 3 times 3 centimeters times 3 centimeters. And the area is 3 centimeters squared. Okay, so what if I know that the area of the square, oops, I just realized I did this wrong, is 9. Okay, so now what if I know that the area of a square is 9 centimeters squared, but I don't know the side length? How can I find the side length out from the area? So how did you get from 9 to 3? So to get backwards, what number multiplied by itself got 9 is 3, right? Or I could just take the square root of 9 centimeters, okay, and it would be 3 centimeters, right? So instead of dividing 9 by 3, I can just take the square root of that. Okay, so if I had the area of 36 and I just wanted to find one side of the square, I could do 36 centimeters squared, and I can take the square root of that. And if I don't know what number multiplies by itself to get 6, I can do that guess and check, right? Working systematically, starting at 1. So 1 times 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, right? 6 times 6 is 36. So I know that the square root of 36 is 6 centimeters. Now, if I was going to try for 64, and I'm going to take the square root of that number, I know it has to be bigger than 6, because 64 is bigger than 36. So, and I also know from the previous video that it's not going to be an odd number, so I'm not even going to bother trying 7. And then I know 8 times 8 equals 64. So it would be 8 centimeters. And then if I'm looking at 81 centimeters squared, I'm going to take this, oops, I forgot to put the little 2 there. Okay, so I'm taking the square root of that. I know it's bigger than 64. I know it's an odd number, so I am going to try 9, and I know 9 times 9 equals 81. So this would be 9 centimeters. So that's how you can use, if I'm looking for, if this is the area of not a rectangle, but a square, then I know I can use the square root to find the side of that square, one side. All right, so square roots are also classified as numbers. So you can operate them like you do other numbers. So you can manipulate them, you can add them, you can subtract them, you can multiply and divide them. So if I have the square roots here, I'm going to do what's inside the square root sign first. So this would be 2, because 2 times 2 is 4. And then I'm going to add it, and then I know 3 times 3 is 9. And so the answer here is 5. Okay, here I'm asking myself what multiplies together to get 25. And again, if I didn't know that, I could start at 1. 1 times 1 is 2. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, right? So this answer here is 5. And I'm going to subtract, and the square root of 1 is 1, because 1 times 1 is 1. And then I'm just going to subtract. Okay, same thing here. What multiplies together to be 16? And that is 4 times 3, because 3 times 3 is 9, and then I'm going to just multiply these together. So doing what's inside the square root first, and then multiplying them together. Okay, so now 36, I know 36 is bigger than 25 and it's an even number, so I know it's going to be an even number, and I know that it's 6 and divided by 3, and that is equal to 2. Okay, so not only can we operate with them, we can also order them. So I don't even need to evaluate these and come up with an answer before I order them, because I know, 4 is smaller than 16 and it's smaller than 9. So I know that that goes first if I'm going from smallest to largest, and I can prove that because that's a 2. Okay, 9, and this would be 3 times 3. So I'm just showing you that I'm proving it. Okay, the next number would be from smallest to largest is 16, which is 4. Next would be 64. Okay, and that is 8. So seeing that it's working right, it's staying in the proper order from smallest to largest, and then the largest one there is 100, which is 10. Okay, so I'm going to order these, and these ones I will evaluate first. So I know that the square root of 81 is 9. 2 squared is 4, because 2 times 2 is 4. This is just the number 6, right? This is the number 25, because 5 times 5 is 25. The square root of 4 is 2. This one I threw in there just as a trick. So you would do the inside first, and I just want you to pay attention to this. So the inside of that would be 36, and then I take the square root of that, which is 6. So these, if you have a square root inside, or if you have a squared inside of a square root, they actually cancel each other out. And so this is proof, right? 3 times 3 is 36, and then I take the square root and I'm back to 6. Okay, so now that I know what my numbers are, I can put them in order. So I have 2, 4, 6, another 6, 9, and 25 from smallest to largest. These problems, they look complicated, but they're really not. Basically, you do everything that's inside the square root first. And I want you to tell me if they're equal or not equal. So 4 times 9, the square is 36, right? So square root 36, and that is 6. Now I'm going to do the square root of 4 is 2 times the square root of 9 is 3, which is equal to 6. Okay, and that's equal to each other. Now I have the next one. I just want you to do this one yourself. So pause the video and you can do the next 2 yourself. Okay, so welcome back. I am going to do 9 plus 16, right? And then I'm going to take the square root, which is 5. Then I'm going to square root 9 over here, and I'm going to square root 16 over here, which is 4. So this is 7. So if I'm looking at this, I know that 5 is less than 7. All right. Again, 144 divided by 4 inside the square root, right, is 36. Okay, so if you need to use a calculator, go right ahead. The square root of 36, I know it's 6 times 6, right? I know what this one is because I know my 12 times table. So I know 144, the square root of that is 12. And so if you know your times tables, your multiplication tables, and your division tables, this will be way easier for you as well. So the square root of 4 is 2, and then 12 divided by 2 is 6. So this is equal. So notice that if I split these for the multiplication, it doesn't make as big a difference as it does with the addition. So now let's check out the subtraction. So try this one on your own. So this is square root 64. This is 10 minus 6, which is 4. So notice those are different as well. Okay, so it would be 8 is greater than. Notice that the open part is facing to the left, so that means greater than. 4. Okay, get this out of the way. Now we're looking at factor rainbows, okay? And the factor rainbow, I like doing the factor rainbows. I think they're fun. So we're looking at the factor rainbows, and we're using the factor rainbows in order to help us find the square root of 144. Okay, so if we're looking at this, what number multiplies by itself? So clearly, while we're looking at that, we can see that 12 has a loop that comes back on itself. So that means the square root of 144 is 12. It also means this perfect square in this factor rainbow is 12. Okay, now I have 256. I'm looking for the square root of 256. So I'm hoping that you very quickly saw that it's 16. And so that also means the perfect square for 256 is 16. And that is your lesson for today.